is Mr. Mike Herbert from ConocoPhillips, and then together with him Fjellheim from Computas. They're going to talk about collaboration for improved decision making in drilling. And a little intro on Mike. He is the Integrated Operations Advisor for ConocoPhillips in Norway. He holds a degree in oceanography, maritime science and engineering. His main responsibilities include the planning and implementation of the Onshore Drilling Centre concept and other integrated operations processes. Mike also manages all drilling IO R&D projects within ConocoPhillips. And in his spare time, he likes to drive strange places, such as in the Antarctica or on top of Icelandic glaciers in nearly no visible light at all. Roar Fjellheim is the Director of Business Development at Computas. He's educated from NTNU as a control engineer, and he's worked in, among other places, CERN and Norske Veritas before co-founding Computas in 1985. And his current responsibilities include managing the Integrated Operations Service Area, business development and project management. He is also an adjunct professor of computer science at the University of Oslo. So,
yeah, thanks, Tom. You can all hear me okay? Yeah? Very good. Okay, this is what myself and Roar talk about today. It's very focused on an R&D project that we've had running for several years at ConocoPhillips. And a lot of it's around decision-making support, collaboration, communication support. And I'll talk a little bit of background, sort of IO background and a bit of history at ConocoPhillips, and also some of the challenges that we have in drilling in ConocoPhillips, but also generally in oil and gas industry. And then also I mentioned about IO, how it's working to improve the situation, and also what are the sort of gaps we see in the future here. And then Roar will continue on, and he will talk about the information technology, the role of information technology in supporting IO processes, decision making and collaboration and so on. So it's a pretty busy slide, but just to give you some history of ConocoPhillips. We started in around, actually it was 2002, 2003, with what we called real-time operations at that time, and it was very focused on drilling, it was very focused on support for offshore, and also some form of remote work. And it's developed over the years to what we see today, which we call integrated operations, and it involves all our business processes. So, for example, production optimization, logistics, subsurface, condition-based monitoring, etc., etc. And it's been a form of continuous improvement in ConocoPhillips. And really, we see big benefits in, for example, the HSC. I think we're more predictive, we have improved planning, we have a second set of eyes. You know, the previous speaker talked about barriers, which is another barrier. We've seen a reduction in risk, and our cost. We have better, more efficient manning, for example. We see better production figures, we're more predictable. So we improve our revenue and so on. So this has become really ConocoPhillips' operating model. So some of the challenges in drilling operations, I always think this is a bit of a deja vu type slide, because you've all seen it probably many times before, but actually the challenges and the problems are still there. So I'll talk a little bit briefly about this. Obviously, we still have a very diverse workforce, both they're physically and geographically dispersed. So we have onshore, offshore, we have people working remotely from different countries. Some we mentioned here, people working from India. We still have not very good demographics in our industry. We have too many grey people in the industry, and we've been it's getting a lot better now for attracting young people in the industry, but we still have a bit of a challenge there. There's a lot of people involved in the decision-making process. We have regulatory pressure, which will be probably more pressure in the future, especially since some of the events we've had recently. Knowledge sharing, resistance to change, these are all some of the things you've all heard of before. On the process side, standards, communication methods and so on. Technology, we're very dependent on IT. We already had an IT problem this morning, I saw. And what was it? It was a password. Yeah. Connections between the companies, interfaces, again that we mentioned, also standards, security, data quality. We still have a huge problem in drilling on data quality. And then other things, we have high non-productive time still, and it rigs costing hundreds of thousands of dollars a day. It mounts up. Very high costs on the Norwegian continental shelf, and there's been lots of talks, lots of presentations from various people around that, and the complexity, increasing complexity in drilling, and also we're moving towards more remote areas. Okay, as most people that know me know that I like pictures, and that other slide there was full of words, but this is just a picture of Stavanger. I just thought, actually it's not quite the same weather, but it's pretty good today, I guess, for Stavanger. But I thought I'd put things in perspective. This is just superimposed on this is Ekefiss, or all the wells on Ekefiss. I think it depends how you count them, but we have 600 to 700 well tracks in Greater Ekefiss. So you can imagine that it creates some problems, particularly where to put the wells, understanding the reservoir, the geology, the overburden because we have a depleted reservoir, navigation, uncertainties, and then you just think of all the people that are involved in the decision making. We have people from ConocoPhillips, maybe some subsurface people, we have some drilling people, they may be employed by ConocoPhillips, or they may be consultants, or they may be from other companies. So they're involved in the planning part and also the execution part. We have a multiple group of people. So communication and decision making is obviously a critical part of the process here. And I think this just shows how difficult it is, and it's not getting any easier either. And also some of these people that are in the decision making process may not actually be living in Norway. They may be working from, for example, we have people working from Alaska in our operations remotely. So, and this just to give you an idea of the scale here. It's 10 by approximately 3 kilometers. IO, there's been so much talked about IO. We have special conferences in Norway, and like I say, we do repeat ourselves a lot. But we've certainly seen a lot of value in IO, and I think most of the companies in Norway see some value in here. We're using data, and particularly real-time data and information more effectively. We have better planning, better preparation, communication and collaboration has improved, and the decision making also has improved. I think we're seeing a much more contractor involvement in the planning and the decision making. We're more predictive, we have better regularity, better efficiency. and so on. However, there's still a lot of potential here in the area of collaboration and communication, situation awareness, for example, integration of functions within a company, for example, in an operating company. I still think we've got a long way to go there. Also, integration between companies is still, I think we have a long way to go there. And actually, later on to mention business models, and I think that's what's holding us back with the integration between companies. Data quality, mentioned that. Documentation, visualization of the decision-making process. How do we document decisions? When some are by email, some are by telephone, some are on little yellow stickies stuck on a drill floor somewhere. So knowledge sharing, we all talk about that. Still think we've got a long way to go there. Training, education, attracting young people to our industry. We work really hard at ConocoPhillips to do that, and I think most companies realise how important that is. And the costs, the business models, I mentioned that, and the industry demographics are still here. I don't know what the percentage is in ConocoPhillips of people of my age, but it's probably too high. So. Oh, that's still in there. Oh, we meant to take this out. Just to show that somebody got it wrong, but maybe they didn't get it wrong. But anyway, Roar, come and explain this. We were going to take this out. But, so I'd like to introduce Roar here. So usually in a double act, somebody starts telling jokes or sings, but I don't think Roar can sing. You want to use that one?
Switch now?
Yeah.
Yeah. I use this one? Okay. Well, first, thank you for the introduction, and thank you to ConocoPhillips for sharing this presentation, letting us share this presentation with them. As Mike just explained, we're in the process of a research program. It's been going on for some time, with the first phase focused on the research aspect of decision making. Can you hear me? Yeah. And the second phase that we are in now is putting the research into software. And of course the internet and everything that goes with it is part of that. We talk about IT today. And this article that Mike found is quite interesting. The first looks like somebody really got it wrong. But if you read what he writes, he has a point, namely that he doesn't believe in 1996 that the reason he doesn't believe that the internet will survive is that it will not support social interaction. And he thought that that was such a basic need in humans that the internet would never survive. But what he didn't understand, or couldn't foresee, was that today internet is in fact the premium medium for social interaction. So in fact he's halfway right, but he drew the wrong conclusions on that. So in our case, interaction is and collaboration is a centerpiece of the work. And as you know, IT is already an indispensable part of integrated operations. There is no question about it. So everything is run by computers. But we think that it has a lot more to offer in the area of collaboration and decision making. And just to mention a few main axes of that sort of new or additional functions that IT can have, is that it certainly is an important tool for data integration, for data visualization. It certainly can help us improve situational awareness and help people collaborate better in making decisions. It can actually support the decisions as such not just the communication, but build in direct support for exploring alternatives and making the right decision. And finally, it can support work processes like the ones that were shown in the first presentation today, putting those processes into a digital form that can help people execute and work processes and make sure that they are executed in a compliant manner. So all these are things that IT can add on to integrated operations. And the main point here is that this should not just be single points on a many-dimensional cube, but it should be provided in an integrated manner. So that's the scope that we're trying to reach in our project, which we call CODIO. Just to illustrate where it fits in the ConocoPhillips operational model. You're not supposed to read everything here, but the main point is that you have a vertical axis of the different actors that are part of the decision-making process, from the management, offshore execution of the drilling operation, onshore support for all kinds of disciplines that are required for the execution. And on the bottom here you have all kinds of IT infrastructure and support applications and so on. And then on the horizontal axis you have different types of activities like the planning, morning meetings, execution of the plans. And on the right hand you will see that there's a point called the small cross up there where it says problem detected ? And that's the focus area for the CODIO project. We want to support the activities that go on when something does not go according to the plan, and they have to find out what actually happened, try to resolve the problem as soon as possible, and come up with some alternative action to come back to the normal planning. So that's the focus area for the CODIO project. So on a very high level, we try to scope the project. It's, as I said, focusing on the problem resolution part of the drilling operation. It will help all these people that we have talked about be better aware of the situation and to be able to exchange information and collaborate in a better manner. Make sure that they get the relevant information. There is no lack of information, but to make sure that they have the right information at the right time is really, it's always been a challenge, and it's even more now when you have such abundance of information available. Decision support is a core piece of CODIO, and we really believe that it's possible to support decision making by making models of the decision alternatives and help people. It's not always intuitively clear what the right course of action should be. We need some processing behind the scenes to explore alternatives. And knowledge management, as Mike also mentioned, we think that as you resolve episodes, you should not forget about it, or it should not just rest in people's minds. It's something that should be stored and be able to, you should be able to search in previous experience and to get back to retrieve relevant information when you have similar problems in the future. And of course we should try to make information as visual as possible. So humans are better at understanding pictures than long reams of words. So these are some of the things that we're looking at in the project. So I thought I'd just run through the various aspects. It's a project, ongoing project, so we don't have we cannot show everything in as it's going to be in the final version, but it's ongoing work. So I'll go through each of those 4 dimensions and explain a little bit on our approach in each of them. The first one having to do with data integration visualization. There would take, maybe I could get a glass of water. The idea there is to get information to the end users and to the decision makers in the format that they can easily relate to, and to be able to show dashboards like the one we have up here, where you get condensed information for all the ongoing on drilling operations. It could be 4 or 6 concurrent operations going on at any time. And then on the top level you can display the status, the main KPIs for each operation, such that decision makers, just by looking at the graph, very rapidly understand what the situation is. And you can provide traffic lights or alert messages that help people focus on emerging problems. For example, that the rate penetration, the speed at which the drilling operation proceeds, is lower than it should be. And this can be very quickly highlighted and observed, and then will lead attention to the right area. If you look at the second area, improved awareness and collaboration, the main approach there is to establish virtual collaboration rooms or workspaces where people can share information and have a look at the same information from different locations. So that's one first aspect. The second is that we have seen in the internet and on intranets the rapid emergence of blogging and discussion boards and so on. So we provide support for micro-blogging related to specific areas of collaboration. If you have specific problems, you have a discussion board for that particular problem, and then people then are able to exchange very rapidly views on the situation and quickly come up with some ideas which will then emerge as part of as a result of the discussion. For example, that somebody is looking at it thinks that this low ROP that we are observing is because we hit a layer of stringers. That is an area of a very narrow but very hard rocks that are very hard for the drill bit to go through. And then somebody else who's sharing the same collaboration board can say that, okay, this looks so, I agree with this conclusion, and we need to have a better look at this particular problem. So therefore we establish a collaboration room for this particular problem. We follow up that problem from then on as a separate interaction between the actors. We start with a high-level view of dashboard. We go down, we get a message saying that something is going wrong in some area. You have some discussion going on, and based on that you decide to engage in a discussion and dynamically create a discussion board for that particular problem. When you're inside that problem area, we provide a set of tools that can be used by the decision makers to explore the problem area. For example, visualization of the history of various drill bits, what they look like after having gone through different types of formations. So you can classify and view this information in different dimensions to see if you can find something that's relevant for the current problem. And you seem to find one drill bit that has had the same kind of hit the same kind of formation, and therefore could give some clues to what could be happening right now. For this particular problem, the drill crew may be posed with the situation that the ROP has gone down, and they have to decide whether to try to just push through and see if they can reach a target without changing the bit, or they have to maybe pull out, strip out the drill stream, change the bit, and with a new and better bit for this particular operation, and then hope that it will, in the end, be a better solution. So there's possible to set up a simple decision tree for these two alternatives. And so another tool will provide help to make that decision, because it's not always straightforward to see which alternative is the best for a particular situation. You need some calculation behind the scenes, and you have to look at the uncertainties involved in different numbers, so the estimated times for pulling out, for changing the bit, for drilling and so on. So this is a very simple decision model, and we're building a library of similar types of decision model for typically occurring decision problems, making them available for the drilling team. So that's for the faster and better decision dimension. And finally, what we call work process support and compliance. The idea here is that when you have, of course, the whole operation is governed by some high-level work processes, and they may exist on different levels. It could be high-level guidelines for how things should be done. There could also be very low-level and detailed procedures that you have to follow, and people cannot have those procedures in their head all the time, and maybe they have to go to a shelf without a manual. We think it's a much better idea to put those procedures into the system as a digital form, so that they can be executed or be actively support the operation. So, for example, the decision in the previous case could be that we need to strip out the drill string and change the bit, and this has to be done according to a certain procedure. Then we start that procedure, and people get active support, guidance for the workflow and guidance for the specific work tasks. This particular example is in fact not the correct work process for this operation, but it's something that we developed previously in the project, and it has to do with geosteering. Same situation with a different type of problem. So again, here we have different types of actors on the vertical level, and then activities on the horizontal dimension. And the blue area here is the collaborative activities that people have to work together to reach a conclusion, and when they have made a decision, the follow-up on the right-hand side of the diagram could be done by different roles involved in the process. Yep. And all this is, as I said, we are now in the process of putting this all into software. We decided to base it on some pretty common software platform, namely the Microsoft SharePoint platform, which of course is mainly, this is very widely available. It's almost ubiquitous in the software industry. But it's extensible, it's a nice architecture in the sense that it has a lot of built-in functionality that can be useful for search and document management and so on. But it's also extensible, so you can put in your own applications and add on to the built-in functionality. And it's all based on, it has an internet browser-based user interaction paradigm, so it fits well into the IT infrastructure of most companies. So we think this is a good platform for this particular solution. So getting towards the conclusion here, CODIO is just one project, and if you try to imagine where the business is going, one way of looking at it whether now it's a 2x2 classification. So if you look at what you can do with respect to automation of decisions in one dimension, and the level of intelligence, the smartness in the solutions on the other dimensions, then maybe we're down here. We can give support to routine tasks. You can provide visits, checklist online procedures, maybe simple workflow systems. Those are already, I think, being used by the industry and certainly within the reach of existing technology. I think that there's potential for automating some of the low-level procedures. Already there are examples in Norway on projects that are automating parts of the drilling process, maybe taking cues from other industries where automation is much more widespread. So I would say starting now, the next 5-10 years, certainly look at more automation. And also on the more intelligent more built-in intelligence. For example, decision support that we work with in CODIO is one example. Better diagnostics, search for information, knowledge management, and have more targeted and better research mechanisms, planning, coordination tools. All these are technologies that I think will be explored by the drilling community over the next few years. And CODIO, I would say, is situated somewhere between the more complex decision tasks support and the current type of current existing technology. And if we look ahead, I think that at least one possible evolution is that drilling, like many other types of physical operations, will be more and more automated, and maybe some part of it can be left to artificial intelligence type of software or autonomous agents. Recognizing situations, makes decisions, and implements or executes the decisions by themselves. But this is certainly not for today or for next year, but for the 5 to 10 years into the future, I think we'll see this. And there are research projects already going in this direction today. Done. Thank you.
Thank you. Yep. And I think we have room for a couple of questions to Mike and Roar.
Yeah, my name is Alan. Mike started talking about the history and bringing it into the future, and you carried on into the future. If we look back, I think to 2006, WOF has made a report together with the authorities to watching into the future how we would take benefit from the integrated operations. And they concluded that within 10 years there will be a cost savings on 250 billions if we manage to take all that benefit over the integrated operations. Now we are approximately a half time so far, and my question first for Mike is, well, I know it's impossible to give the exact numbers, but you were also mentioning a lot of challenges we still are facing when it comes to execute all the integrations here. So how far do you think we have got at the moment? Have we managed to achieve 50% of these targets, or have we still far more to go? And have there been new paths coming up, new directions according to what the visions made 5 years ago in this area? Thanks.
Okay, on the money side, on the savings side, I think there's been some well-publicized papers and reports, presentations from various companies, Statoil, ourselves, about the value of I/O, and I think we are on the road for recovering what was estimated, and I think we will exceed that. Certainly in ConocoPhillips, when we're talking about this has been published, 2 to 5% production. That's a really big number. So Veritas is still the largest field in Norway. So I still think there's a lot of potential, and also when they were doing these estimates, I think they were very conservative. So what was the other question was about things we didn't think of, or was it?
Yes, well, me and you have worked a lot and talked a lot about this, and we also see a lot of spin-off here, that new doors have been opening that nobody had imagined. So you think these plans and visions also have been corrected and changed according to...
Absolutely, yeah. Well, I mean, we're talking about technology, IT, networking, and so on. I mean, that develops exponentially, and there's nobody really can predict how that's going to go. So we've adapted, we've improved. We're a part of this sort of continuous improvement process which we have going on for this, and most other companies do as well. So you have to adapt to different technologies. And I see people here with iPads, and I see the government in Norway are going to be using iPads now for all be given iPads, though some of them I'm sure won't be able to use them, but it's another discussion. So if you go back 10 years, people would have laughed at you if you said that was going to happen.
One more
with
question.
Stoltenberg. Stoltenberg is going to be using his iPad when he's talking to Barack Obama. Isn't he talking to Barack Obama then? He's got 45 minutes. You better say harsh instead of hash.
More questions?
What's the hardest thing? Is it managing the data or getting people to use it? These are massively complicated systems, aren't they?
I think it's both. I think data quality is a big struggle, I think. Because unless you have data quality, you can't use the data effectively. If you're doing modeling, simulations, stuff like that, the quality is not there. It's very, very hard to trust the data or understand the uncertainty of the data. You know, Eric would be sure talking about that as well. So. And also to get people to work together. We're very sort of partition organisation between drilling people and service companies. I still think that's where we have struggled a lot there. And also roles and responsibilities. We don't talk too much about that. But if you've got somebody working in India or Alaska or UK or something, and he's part of your team making decisions, the responsibility side of it is unique, but that's a massive bit of a challenge.
Right, so no further questions. So thanks a lot, Mike and Noah. And we will welcome Charles a bit further.